Hello everyone, I'm Xiao Gang. Okay, now let's write this damage detection logic. But actually, we still have a lot of work to do. For example, we haven't made the GEC specifically for calculating the heavy machine yet, and we also haven't made the special effects for the heavy machine. Because the situation is a bit different, we need to finish writing the damage detection logic first. So for this damage detection logic, we need to create a collision box and attach it to the character socket, then enable collision after it is spawned. This part is also quite important, quite core. So first, let's go to our VS. We should have left some space here earlier. It should be inside the damage actor. Here, inside the EMG actor, we need to make a head box specifically for detecting such a thing. A head box for damage. Let's rename this first. Then I'll go through them one by one and explain each to you. First, this head box. Let's break it down one at a time, right? Then let's include the header file first. What does this header file do? Everyone should be very familiar with it. Okay, then here are the tags and actor and minimal dependencies. Then include the reflection file. Then we need to forward declare the base of this actor, and at the same time, let it inherit from after inheriting from the actor. We first give a red. After having this red, we first definitely root component. As for this root component, we plan to use a collision box. Then this is just a root component. A scene component. We need to create it. Okay, then here, let's first write the hook function. After writing the highlight function, we need to prepare I'll be faster in that part, because I've written this too many times. When we were working on the official case earlier, doing the first-person shooter, this function was very familiar, right? Then here, as long as there's a collision, remember it must be EU function. Otherwise, your collision might not take effect. Okay, then there is a function here that returns the collision box, which might need to return our. Let's list them out first, then later. Actually, for this collision box, we want it to support dynamically setting its size. That is, we want it to be able to be generated at runtime. So we don't want you to instantiate this object and then click on this collision box. We want a direct entry point to pass parameters. So here we are going to have two parameters to. What are the two parameters for? To modify the size and position of this box. That's all. And these are the functions of these several functions. And that's one of ours. Because we are going to send a game event. When we are all sending it, we need to mark it. What exactly this game event is. So we need to pass a game event here. So that's the meaning. And then here, that is, we will check here. The object we passed in, whether it has already been damaged. If it has been damaged, we will return a false, so no further damage is needed. And here are some of its default constructor functions. And the most important thing is these two member variables. This variable corresponds to this variable. That is, we can specify that we send a game event. This target is just for storing. We have already dealt cumulative damage because we don't want one slash to trigger twice. One slash deals damage to one object once, but in the actual collision detection process, during the swing of the slash, it might hit the target twice. That's the situation, okay? Now let's implement it one by one. First of all, inside this hitbox, we create its definition, and then this is. I should check for tick. It probably doesn't need tick. Let's turn off tick. Should be fine. Then just give it a false. Then pay attention to the header file. For the header file, let's just include it directly for now. First, we use this box contents, this collision box, this rectangular type, this collision box. Then we also need to go to ASC, so we include the ability systems blueprint function library. Then, because we have this place and some character class and this kind of ability, things like that. So we just include the common file. Then we create a root node. Then we assign this root node, but this is just a scene component. And then we create our collision box attach the collision box to our scene component. Then here, set the lifespan to full 0f seconds. Then this collision box, we do not allow it to spawn on the client, and it does not need network synchronization. Of course, when you debug or when we test, if you want the client to see this box, you can also let it spawn. But for us, we don't do that. Next, let's write this first. Let me take a look. Let's write the remaining functions first. We write this, and in the end, writing this is quite complicated. This black damage is actually mainly for this box might be used elsewhere. We just need to repeat this black part. Then, also this. Set the relative size of this box. And also set the size of this box. Actually, for them, it's mainly about getting our component. Then you set its relative position. And directly set the size of this component. Okay, then next is our begin play and this tick. Actually, here, there should also be this. Whether this damage was dealt, we created. Okay, then when determining whether damage was dealt, how do we judge it? It's relatively simple. We just iterate. Use a for loop. If we can find it in the for loop, then it proves we have already damaged it. If not, then we haven't. Then in the tick, we just call the parent block. Then in begin play, we also call the parent class first. Then we need to do something at our location. This binding of the collision box, because we need to bind our U function to this collision box's overlap event, and at the same time, this box in the game. We can just tie it. After doing this, after it's done, let me take a look. Heading game should be fine. Okay. Next, we'll write the most complex part, which is handling the collision. When our other objects hit our collision, we need to do some processing. First of all, we must exclude ourselves. That is, when we generate our box, there will be a parameter. Like t inside this box. When we spawn, we often pass this parameter. Then, when we get our own, we definitely cannot put ourselves. So we cannot put ourselves in, right? Secondly, this object must be converted into our character class. If the conversion fails, both sides must be this character class. But sometimes we may not need it. But for this heavy work of ours, this notification for damage detection, we need both sides to have an ISC. Only then do we proceed. And we must do this on the server. We mainly perform related work on the server. If it is not on the server, we ignore it. But it is precisely here that we considered there might be a standalone or listen server scenario. Therefore, we did not directly judge it as a dedicated server. As long as it is not a client, we consider that in other forms, it needs to execute the logic related to this damage detection. Okay, next, we will prepare the data for a game event. As for the data of this game event, then this tag. This tag is the tag from this place. This tag is the tag passed in when we generate it, because we might apply this to multiple situations. So, this place needs to be configured flexibly. Then, who causes this down? It is whoever generated this box. And the target is the object that was hit. This R target is the object that was hit. Okay, if we talk about this time, we need to determine whether we have dealt this damage to it. After dealing damage, we will not deal damage to it again. So then, at this point, since we have already entered it, we must mark it here. Otherwise, the next time you enter, it will deal damage again. Then at this point, we check whether this path tag is empty. As long as this path tag is not empty, we will apply it to it. Just activate this hit processing. GA's world right here. Okay, so we might trigger multiple of these path tags. Now let's loop it. Send event to the receiver's location. No, not the receiver. This is the attacker. In the previous lesson, in our blueprints, we have a wait game event right? Its data is sent from here. Sent from here. Okay, good. Actually, at this point, our collision box is basically done. We can compile it. If we place a box on the field, it will, for players who touch this box, send a game event for this test. And the specific game event tag sent is configured when our box is generated. To be assigned and a construct. Okay, you can see that our compilation here also passes without. Next, we need to write another animation notification and then generate when our animation plays and reaches a specific point to generate this collision detection box. Okay, see you in the next lesson.